gotta hit
of the refrigeration cycle. The objectives are to gain a basic understanding of the properties and relationships of matter, temperature, and heat. To identify the four major components in a refrigeration or air conditioning system and explain their purpose. To demonstrate an understanding of the pressure-temperature relationship of refrigerant as it flows through the system. And to understand the effect each component has on the refrigerant during the refrigeration cycle. Whether you realize it or not,
I feel like it's a better quality on
air
here.
conditioning affects our daily lives, from the homes we live in to the
Thanks for
places we
condensing.
work, to keeping food fresh and safe to eat. Air conditioning and refrigeration contributes greatly to the high standard of living we enjoy today. Have you ever wondered how the process of refrigeration works? This tape will introduce you to the basic concept of the vapor compression refrigeration cycle, the means by which most modern air conditioning and refrigeration systems operate.
Here we go.
Section 1, Terminology. To understand the refrigeration cycle, one must first understand some basic terminology. The second law of thermodynamics states that heat will only flow from a substance at a higher temperature to another substance which is at a lower temperature. Cold can be described simply as the absence of heat or a lower than desired temperature. Keep these two things in mind as we discuss the refrigeration cycle.
Pretty short on.
Everything around us is composed of matter, a substance that takes up space and has weight. The three states of matter are solids, liquids, and gases. Heat content and pressure work together to determine the state of matter. A change of state is a condition in which a substance changes from a solid to a liquid or a liquid to a gas with the addition of heat. A substance can also change states from a gas to a liquid or a liquid to a solid with the removal of heat. Temperature is a measurement of the level of heat expressed in Fahrenheit, Celsius, Rankine, or Kelvin. Fahrenheit is the temperature measurement scale used mainly in the United States. Celsius is the metric system temperature scale used throughout much of the world. Rankine is the absolute Fahrenheit scale where 0 is called absolute zero, the point where all molecular motion stops. 0 on this scale is equal to minus 460 degrees Fahrenheit. Kelvin is the absolute Celsius scale where 0 is called absolute zero, the equivalent of minus 273 degrees Celsius. An important term we will use throughout this video is heat. Heat is a form of energy that sets molecules in motion and acts on a substance to produce either an increase in temperature or a change of state. The types of heat important to this discussion of the refrigeration cycle are sensible heat, latent heat, and superheat. Sensible heat is readily measured with a thermometer. It is heat added to or removed from a substance to cause a change in temperature. Latent heat is heat energy absorbed or rejected as a substance changes states with no change in temperature or pressure. Superheat is sensible heat added to raise the temperature of refrigerant vapor above its saturation temperature. Evaporation is a condition that occurs when heat is absorbed by a liquid, changing the liquid to a vapor. Condensation is the changing of vapor to a liquid at a particular pressure and temperature by removing heat. Subcooling is the temperature of liquid refrigerant cooled below its saturated pressure temperature and is a form of sensible heat. Learning these These terms will help you understand how the refrigeration cycle works. Prepare for quiz 1. The three states of matter are A.
I'm gonna stop it for just a second. You guys get a chance to answer those questions, bro? Everybody done?
Yes.
Everybody done it before?